Hi students, this is Vijay Ramakrishna. I am teaching physical science in MJP APBCWR school, Samanasa. Students, we all know about samosa. When we eat samosa, we know that the outer side is cooler, but the inside is hotter. Why the inside is hotter? The ingredients used inside the curry have high specific heat. The ingredients have high specific heat. That's why the samosa is hotter inside and cooler outside. So today we discuss about specific heat, the concept of specific heat. First, specific heat. Specific heat is the amount of heat. Specific heat is the amount of heat required to rise the temperature of unit mass substance by 1 degree centigrade. Once again, specific heat is the amount of heat required to rise its temperature of one unit mass of substance by 1 degree centigrade. Why to use the specific heat of a substance is the amount of heat required to rise the temperature of unit mass of substance by 1 degree centigrade. We take unit mass of substance and we heat the substance to rise 1 degree centigrade. The amount of heat energy required is called specific heat of this substance. Specific heat of this substance. Once again, we take unit mass of substance and heat the substance to rise the temperature from initial temperature to rise 1 degree centigrade. To rise the 1 degree. Initially it has 25 degrees centigrade. To rise the temperature means after heating it reaches 26 degrees centigrade. What is the difference? Difference is 1 degree centigrade. The rising temperature is 1 degree centigrade. To rise the temperature 1 degree centigrade, the amount of heat required is called specific heat of this substance. Specific heat of this substance. To understand the specific heat, we need to discuss more activities. Let's know about the activities. To understand the specific heat concept, we need to discuss two activities. In this first activity, we take a large jar with water and heat it up to 80 degrees centigrade. Water 80 degrees centigrade. Take a large jar with water and heat it up to 80 degrees centigrade. And take two identical boiling test tubes with single hole corks. And one is filled with 50 grams of oil and another one is filled with 50 grams of water. One is filled with 50 grams of oil at room temperature. And another one is filled with 50 grams of water. This is also at room temperature. At At first we take water, heat applied with 80 degrees centigrade, and then take two identical boiling test tubes, fix single bowl of box, and one is filled with 50 grams of oil, and another one is filled with 50 grams of water. Both are at room temperature. Now insert two thermometers to the holes of corks into boiling test tubes. Now observe the readings. Of thermometers for every 3 minutes. Observe the readings of thermometers for every 3 minutes. Observe the readings of thermometers for every 3 minutes and note it on your notebook. What happened? What you observe for every 3 minutes? We observe that the rising temperature in oil containing test tube is higher than that of the boiling test tube which is containing water. That means the oil rises temperature quickly when compared to water. Oil rises its temperature quickly when compared to water. Here we raise a doubt. Are we supplying the same heat energy to both test tubes? Yes, we supplied same heat energy because we have kept both test tubes in the jar of hot water which is containing 80 degrees centigrade temperature. So we deliver same heat energy. So but the rising temperature is different in both test tubes. Oil containing test tube is higher rising temperature when compared to water containing test tube. That means rising temperature in oil is higher than compared to rising temperature of oil. So from this entire activity, what we observe? We conclude from this activity the specific heat of substance depends upon the nature of the substance. The specific heat of the substance is depend upon the nature of the substance. Specific heat of the substance depends upon the nature of substance. Specific heat of the substance depends upon the nature of the substance. Here we used two different substances. One is oil, another one is water. That's why rising temperature in oil is higher than compared to the rising temperature of water. I hope you understood. The next activity. In this activity, we take two beakers of equal volume. We take two beakers of equal volume. One is filled with 250 grams of water, and another one is 1 kg filled with 1 kg of water. Here we take two beakers of equal volume, and one is filled with 250 grams of water, another one is filled with 1 kg of water. And now note down the initial temperatures. Initial temperature should be same because there are room temperature. The room temperature is the initial temperature. And now heat both beakers till the temperature rises 60 degrees centigrade in each beaker. The temperature rises 60 degrees centigrade in each beaker. And so we heat both beakers. We heat both beakers till the temperature rises 60 degrees centigrade. And note down the heating time required to reach 60 degrees centigrade in each beaker. Note down the time required. That means heating times. In your notebook. Note down the heating times in your notebook. What do you observe? And which beaker needed more heating time? You observe that 1 kg of water needed more heating time when compared to 250 grams of water beaker. That means 1 kg of water needed more heat energy to reach 60 degrees centigrade. That means to rise its temperature when compared to 250 grams of water. That means we need to supply more heat energy to greater quantity. We need to supply more heat energy to greater quantity when compared to lesser quantity of mass. That means the amount of heat energy required is directly proportional to its mass. That means Q is directly proportional to M. The amount of heat energy is required is directly proportional to mass of the substance which we use. When delta T is constant. Here we are rising the temperature to 60 degrees centigrade. We have fixed the temperature of 60 degrees centigrade. That's why change in temperature is constant. The change should be 60 degrees centigrade. That's why delta T is constant. When delta T is constant, Q is directly proportional to M. That means amount of heat energy rises when mass increases. The amount of heat energy required also increases. We need when the greater quantity of mass, we need to supply more heat energy. We take greater quantity of mass, we need to supply more heat energy to raise the temperature to 60 degrees centigrade. That means to constant temperature. To reach the constant temperature of a greater quantity of substance, we need to supply more heat energy. This is equation 1. And let us discuss another activity. In the next activity, we take beaker of 1 liter water. Take a beaker of 1 liter water and heat it on a constant flame. Heat it on a constant flame. And note down the temperature changes for every 2 minutes. What do we observe? The temperature change. The change in temperatures rises. With time is constant. The change in temperature in this beaker. The change in temperature, that means delta T. The change in temperature rises with time is constant. That means the change in temperature delta T is directly proportional to heat absorbed by people. Notice that the change in temperature rises with time is constant. The change in temperature rises with time is constant. That means for same mass M, the rise in temperature, the change in rise in temperature, is directly proportional to heat absorbed by it. That means Q is directly proportional to delta T, where M is constant and N is constant. For same mass, the rising temperature, the rising change in temperature is directly proportional to heat absorbed by it. That means if heat absorbed by it is rises, temperature in change is rises when M is constant. That means same mass of substance. From the two equations, Q is directly proportional to M, where delta T is constant and Q is directly proportional to delta T when M is constant. From both equations, that Q is directly proportional to M delta T. From this equation, Q is equal to Ms delta T, where S is constant. From this equation, we got S equal to Q by M delta T, where S is specific heat of the substance. S is constant and S is specific heat of the substance. Specific heat of the substance is the amount of heat required to rise the temperature of unit mass of substance by 1 degree centigrade. Here, specific heat of the substance is the amount of heat energy required. To rise the temperature 1 degree centigrade of unit mass substance. Specific heat of substance is the amount of heat energy required to rise the temperature of unit mass substance by 1 degree centigrade. This is specific heat. I hope you understood about specific heat. Now the units of specific heat. In CGS system, the units of specific heat are calorie per gram degree centigrade. In SI system, joule per kg Kelvin. The units of in CGS system, calorie gram degree centigrade, and in SI system, joule per kg Kelvin. I hope you understood about specific heat. We will continue